All right. I am going to divide my page into two. All right. On one side is the side where you're going to do the lab, and this is the left side of your lab notebook. Is that clear? The purpose of your lab is to determine the specific heat of a metal. All right? The purpose of the lab is to determine the specific heat of the metal. Now, I'm not going to write the materials. All right? I'll leave that to you, but we're going to write the procedure. Now, on your left side, all right, let's brainstorm the process. Let's try to write the procedure, all right? We have a little bit of an idea by doing calculation how to calculate the specific heat of a metal. Yes? All right, so we said heat lost by metal equals heat gained by water. Yes or no? Why is the class so awfully quiet? You're a talkative class, aren't you?
It's a lot of information. We're trying to pay attention.
Okay, do not get scared that I'm recording, all right? Okay, I don't want you getting, okay? I want you to be your, and this is not even the recording for which I got your signature. This is just for a student, all right? Okay, I want you to be your natural self. Do you hear me? Okay, I assumed wrong? That's fine then. I like the silence also sometimes. Helps me teach and helps me think. All right. Now guys, even though we have this equation, heat lost is always, what sign? Negative. Don't forget that. Heat lost is negative and heat gained is positive. So it is mass of the metal times the specific heat of the metal times the change in temperature of the metal. Is that right? The change in temperature of the metal equals, how do we report the heat gained by water? It's going to be mass of water times the specific heat of water times the change in temperature of water. Yes or no? Now, if I want to expand this change in temperature of metal, I really need the final temperature to which the metal goes, T final of the metal, and I need the T initial of the metal. Is that right? And for water also, I need the T final of water and the T initial of water. Is that right? So I'm going to make two columns, and I want to know what are the things that I need to record or take care of in this lab. So I'm going to make two columns. I'm going to make water column, or should I do metal on this side? Because you guys have written metal on this side. All right? I should write metal on this side. I'm going to write water on this side. Can you tell me what are the things I need to measure to substitute in that equation? One at a time. Can you put up your hand and tell me? Yes, Kate. Temperature of what? Temperature of the metal. So Kate says, temperature, what temperature is it? Initial temperature of the metal. She says, I need the initial temperature of metal. I have to record that. What else do I have to record? So this is one thing that I need to record. What else do I need to record? Yes? I need your contribution. Yes?
Mass.
Mass of what? Mass of metal. Okay. I need mass of metal. Okay. What else do I need? What else do I need to measure in the lab? Initial temperature of the water. All right. I need the initial temperature of water. What else do I need? Yes. Mass of water. All right. I need mass of water. What else do I need? Is there anything else that I need, or am I done? Final temperature of what? Both. So can I say final temperature of metal? So final temperature of metal. So guys, am I going to get a different final temperature of water? Should I be measuring that? Rachel says yes. I will get a different final temperature of water. Am I going to, how many of you say that I'm going to get a different final temperature of water? How many of you feel that's something I should record? How many of you think it's enough if I record the final temperature of the metal? How many hands do we have? 1, 2, Rachel, only one temperature, final temperature of metal, that's it. 3, 4, 5, 6. So the rest of you think I should have a final temperature of water. Is that right? Yes or no? Let's go back. Let's go back to this problem. All right? Let's look at this region of the discussion. What did we say? What did we say? The final temperature of the metal is going to be the same as the final temperature of water. Are they going to be any different from each other after a certain period of time? Do we need to record a separate final temperature of water and a separate final temperature of metal? Are they going to be one and the same? Okay, so let's make sure we understand that. All right, so this is going to be the final temperature of water is going to be the same as the final temperature of the metal. They're going to be the same. Yes or no?
Yes.
Okay. So there are 5 different measurements I need to make. Or are there only 5? How am I going to start the experiment? I already explained how I'm going to do the experiment. Is that right? I drew all those pictures. Can you tell me where I start off first? What should be my first step? Anybody in class? What do I do first? Yes, Sonia.
Put the water in the container.
That one? Put the water in the container and heat it? Is that what you're showing? The one? Okay. So she's referring to my hot plate, and let me explain that. Did I say in my problem that my temperature of the metal was really hot? It was at 125 degrees Celsius. Now I can choose to heat the metal different ways. Yes or no? I can take the metal and put it on a flame and heat it up. Is that right? But the problem is I cannot measure the temperature there. Is that right? Of the metal. So what I choose to do is, right now where is my metal? It is in boiling water. What can you say about the temperature of the water and the boiling water and the metal? They are the same. So can I say this initial temperature of the metal is nothing but the temperature of the boiling water? Is that right? So that's why I did that. That's a step I've already done for you to give you what? To give you the hot metal. Does that make sense? So in order to do your lab, what is it that you actually need in this lab? What do you need? Tell me, what are you going to measure first out of all this? Are you going to measure the initial temperature of metal? What are you going to do first? What is it? You're going to measure the initial temperature of water? Is that right? So, water is cold. Is that right? And here is my cold water. Okay? Here is my really cold water into which I'm going to put the hot metal. So, Kate, if I need this, do I just take any amount of water I want and I put my thermometer in? Okay, so I need to get the mass of the water. So how am I going to get the mass of the water? What am I going to do first? Okay, so I hear Alyssa say that this is my calorimeter and it's going to have its own mass. So what I need to do is I need to put this on a scale and get its mass first. Is that right? Or you could zero it out. So can I say my first step is, do you feel I can write that in my procedure? Okay, you all agree? Okay, so my first step in the procedure is zero out the mass of the calorimeter. And then do what? And then after this, what should I do? Add water. So they're saying add water, but here is my question. How much water should I add? How much water do I need? What am I going to do with the water? Just measure its temperature or do something more? Yeah? Somebody said something else? Yes, Dewey?
I think calorimeter.
Okay. So I can take any amount of water. I can fill it up with water. Or can I take this little water? How much water should I take? What's the purpose of my taking water? It covers the metal. So I'm going to ask you students to take 3 pieces of the metal. All right? You should take enough water to cover the 3 pieces of the metal. All right? Now, can I ask my students another question? Does water have a high specific heat or a low specific heat? What is the specific heat of water again? What are generally the specific heat values of metals? 0 point something. So, since the specific heat of water is high, does it need a lot of heat energy to heat up or less amount of heat energy to heat up? A lot of. So, I'm taking water to immerse the metals, but if I take a lot of water, will I need a lot of heat to heat it up for its temperature to make a difference? Is that right? So is it a good idea to take a lot of water? Will you be able to measure a significant difference in temperature? Not really. It may not even increase that much. Do you understand? So how much water will you take? Enough to cover the metals. Alright? So how much water do you think that will be? I'm going to say add approximately. Now you can eyeball it. Is that right? You can add 3 pieces of metal and see which is a correct number that you feel is relevant to your experiment. Is that understood? Approximately 50 ml of water. All right? The main idea is it should immerse the metal pieces. And we should be careful not to take a lot of water because it won't give us a significant increase in temperature. Yes or no? As little as possible, but enough to cover the metals. Now what do? I took water. What should I do next? Yes. Okay, record the mass of water. Record the mass of water. So I got one measurement down. What is my next step? What is my next step? These are the things I need, guys. What is my next step? What? Okay, record the temperature. Record the temperature of cold water. Can I say that? Cold water in the calorimeter. What should I do next? What should I do next? Okay, so Kate says find the mass of the metal. All right, so I can show you how I'm going to provide the metals. Is that right? It is placed in a hot water bath and it is boiling there, and the temperature is the same as that of the metal. Is it a good idea to take the metal, mass it first, or should you postpone it? Postpone it. All right, so then what do I do next? Add what? Okay, add the metal, add 3 pieces of the metal. That's wrong. Anybody disagrees? Huh? Okay, the water, I'm providing that to you, all right? Add 3 pieces of metal from boiling water to the calorimeter. Well, if I hadn't been boiling it, you would boil it. You're right about that. Is that right? You'd first put it to boil. What do I do next? What do I do next? Huh? Okay, let it sit for a couple of minutes. Let it stay or for a couple of minutes. How am I going to know how many minutes I'm going to stay there? What is my indicator? How will I know how long to wait? Yes, Alyssa?
Maybe the water's half bubbling.
Whoa. We are taking the metal. It's in boiling water. I'm putting it into cold water. You think it's going to boil? Okay. Just making sure. So how do I know how long to wait? What is my indication? It will stop steaming? I'll use my eyes and it will stop steaming? Do you think the temperature will go up that much? What will happen? Do you have an idea, Ben? Very good. You will know to wait enough till the temperature stops changing. Okay. What is my next step? What is my next step? What do I do? Have I recorded everything? I'm done? No. Okay, what more do I need? I need to find my final temperature. All right. Record the final temperature. Okay, guys. Let's see if we can cross out a few of the things. All right. Did you get the initial temperature of water? Is this the initial temperature of water? We got that? I can cross it out. Did I get the mass of water? Is that the mass of water? Can I cross it out? Did I get the initial temperature of the metal? Did I record that? So what should be my next step? Alyssa, we're focusing here right now. Initial temperature of the metal. How do I get that? Okay, so you will record the temperature of boiling water. Now let me ask you a question of boiling water. I know boiling water's temperature doesn't change, but even then, at what point in this experiment should you actually record the temperature of the boiling water? When would it be appropriate to record the temperature of boiling water? Yes, Ben. While the metal was in it. So can I push this step from the boiling water? Can I push it right up here? Can I push that step up there? Is it a good idea to record the temperature of water and then add the metals because that's the temperature they are both at? Is it a good idea to do that? Okay. So let's go through this list. Did I record the initial temperature of the metal then? Did I record the mass of the metal? How am I going to do that? When it cools, hasn't it already stopped cooling? Hasn't it already stopped? So what am I going to do now? How am I going to record the mass of the metal? What do I do? I'm sorry? Somebody said something?
Zero it out.
Zero out what? The cup of water? The metal is inside the water. So how am I going to do it? And it's recorded, we recorded the final temperature. Is that right? So how am I going to record the mass of the metal? It's sitting inside my calorimeter. How am I going to record the mass of the metal? What am I going to do? Yes. It's a piece of metal. What can I do? Take it out. All right? Pour out the water. It's a piece of metal. I can remove it, but what do I need to do before I mass it? Dry it. All right? Remove the piece of metal. Remove and dry the metal and mass it. And record its mass, however you want to write it. Okay? So did I record the mass of the metal? Right? What about these two? Have I done it? Have I recorded the final temperature? Okay? So am I done? Am I done with all my steps? So that is your lab. And how much more time do I have? 20 minutes. Okay? So shall we do one trial for the lab? Or should I teach you one more problem type? Because none of the classes have done it, and we can all do it together as a class next time, like all my classes. Will that be a good idea? Yeah. I'm gonna do one thing though before I get on to teaching you one more problem type. I have goggles, and I have not distributed goggles in this class. Okay. All right. Here is how it's going to work. Are you all? Oh wait, I can't do this. I have to number it. I need to know what number to give you, right? Wait a minute. Okay, so let's see. Can you take out this sheet of paper and we're going to work on, I gave you practice problems, right? I'm going to stop,